Good afternoon, everybody. Welcome back to another glorious day. Today, we're going to be working out of your Mentoring Minds math book. So I highly recommend that you have this out while you go through this lesson so that you are able to follow along and take the notes in the book. Now, okay. Just wanted to make sure I could write on this with marker and not damage anything. All right, but I'm going to go ahead and put paper under here just to be on the safe side. All right, so the first portion of this page says each of these figures is a parallelogram. I'm going to start by underlining that. A parallelogram is a closed figure where both sets of opposite sides are parallel. It's also only a quadrilateral, okay? So I'm going to make a note that we have a quadrilateral with two sets of parallel lines and so each of these figures is a parallelogram, meaning it's a quadrilateral, so it has four sides, and it has two sets of parallel lines. They want us to measure the sides and angles of the parallelograms. That's pretty easy and straightforward. We can do that. I'm actually going to switch to pen. That way y'all can see my notes a little bit better. So I'm going to start with inches. Now remember, when you're using a ruler, you need to find where the 0 is because whatever you're measuring needs to start at 0. So I'm going to put the vertex of this side there. Now this is not coming out equal. So I'm going to check centimeters just to be on the safe side. So once again, I find 0. I line 0 up with the very beginning of my line. And it looks like this is not equal either. So let's see here. This is 4.2 because this is 4 2/10 centimeters. Okay. So I'm going to measure this bottom one, and this one is 2, so this one is also 4 2/10 centimeters. This one is 7/10 centimeters long, and sorry, 1 7/10. I apologize. And this one is also 1 7/10 centimeters. Okay. So we've measured the sides of the first parallelogram. Let's look at the next one. This one's exactly 2 centimeters. This is also exactly 2 centimeters. 2 centimeters. And 2 centimeters. So these are all congruent sides. This side and this side are congruent, and this side and this side are congruent. Now we use 1 slash with these two because they're the same, but since these two are a different measurement, we use 2 slashes to indicate that they're a different length from these two. But since all 4 sides of this parallelogram are equal, then we use 1 slash for each of them. Now let's take a look at the last figure. It would be 3 7/10 centimeters by 3 centimeters by 3 7/10 centimeters and 3 centimeters. All right, now that we've measured all of the sides, now we need to measure the angles. So what I'm going to do is I'm going to put the degrees next to each angle as we measure them and try to do so in a way that's as organized as we can possibly make it. So once again, I'm going to need my trusty protractor and my ruler to help me extend these. We put our vertex in the midpoint. We line up one side of the angle, and then we use our ruler to help us find where it would cross. So this one is, let's see here, this one is 46 degrees. I'm going to turn my protractor upside down this time. Line up the vertex, line up the 0. Use my ruler to extend the line. Now I know that this one is going to be greater than 90 degrees by looking at it. So I need to go with the numbers on the bottom. It's 144 degrees. And line up the vertex there. And go down. This one's definitely going to be smaller than 90 degrees. And this one, oops, I gotta get this lined up correctly. There we go. All right, and this one is also 46 degrees. Now I have a hypothesis that, which is an idea that we can test. If you remember from science, your hypothesis is your statement that you can test, your statement of what you think is going to be true. My hypothesis is that because these two angles were equal, that these two angles are going to be equal as well. So let's test out my hypothesis and see what happens. So I'm going to line up my midpoint. And see here. No, I was not correct. This one, or maybe I'm messing this up a little bit. This one is actually 134 degrees. So let me go back and double check one of my measurements because we always can make mistakes. It happens. So I'm going to line up my midpoint again. I'm going to double check. And I made a mistake because when I was measuring, I wasn't careful knowing that 130, then 140. I was measuring it as 140 going this way. So I actually messed up. That's 134 degrees. So my hypothesis is correct because when you have parallelograms, they are going to create angles that oppositely are equal. So 46 is opposite of 46, they're equal. 134 is opposite of 134, they're equal. So now we need to measure the angles on this figure. I know that this is going to be more than 90 degrees. And it comes out to 105 degrees. Let's see, I'm going to darken that up to where it makes it actually look like a degree mark. I'm going to line up this angle. This one is also 105 degrees. Now, I have a hypothesis. I hypothesize that because these two angles are 105 degrees, my hypothesis is that all four of these are going to be 105 degrees. Let's see. Or actually, I measured that one wrong. I need to go back and take another look at that because I just noticed that this angle is smaller than 90 degrees. That's not even a 90-degree angle. So I measured incorrectly, which everybody makes mistakes. And what happened is my mind said, oh, it's a parallelogram. And since this one was obtuse, this one's going to be obtuse too, because I didn't slow down. I made the mistake because I wasn't double checking my work as I did it. But I went back and caught it. So truthfully, this angle is actually 75 degrees. And the other reason that my brain knew that something was wrong is that, and I'm just going to put a note up here on this, all four angles in a quadrilateral total 360 degrees. So if all four of these angles were 105 degrees, I already know that that's incorrect because 100 plus 100 plus 100 plus 100 is 400. And all four angles can only total 360 degrees. So I knew that I made a mistake somewhere and I needed to go back and correct it. All right, so let's go pick it back at look at this one. So on this next angle, it is going to be larger than 90 degrees because it's definitely, you know, if I could even line the ruler up. If I line up the ruler there, this edge is a 90-degree angle. And this angle is larger than that. So it's going to be an obtuse angle, and it's going to be larger than 90 degrees. So I'm going to line up my midpoint and line this up. It slid. There we go. Now this one is 105 degrees. Now I'm also coming to a conclusion now. So with this parallelogram, opposite angles were equal. With this parallelogram, opposite angles were equal. With this parallelogram, we've already proven that one set of angles that are opposite each other are equal. I'm going to hypothesize that this angle is also going to be 75 degrees. So let's take a look. Line it up. And this angle is going to be acute because it's definitely smaller. So I need to make sure that I am reading the right point. I need to be reading up top, and exactly, it measured out at 75 degrees. All right. So far we have at least two congruent side lengths. We have at least two sets of congruent angles. And we also know that we have opposite sides that are parallel. We can look at this and say, well, if this line continues forever and ever and ever and ever and ever in both directions, and this line continues forever and ever and ever and ever in both directions, they're never going to touch. They are going perfectly horizontal. So even if I continued it out forever and ever and ever, they're not going to connect. That makes parallel lines. So this line and this line are parallel. This line and this line are parallel. So we could even label these. So let's see here. A, B, C, and D. So we know that line BC is parallel to line AD. We also know that line AB is parallel to line DC. So that's a lot of information that we're able to compile over one figure. We have lengths of the sides, we have parallel sets, we have congruent angles. We could even label this as angle BAD. Angle bad is equal to angle DCB. I'm sorry. Yeah, BAD is actually equal to angle DCB. Yeah, DCB. And then angle ABC is equal to angle ADC. Okay, lots of information there. And we can say the same things here. This line is perpendicular to this line. This line is perpendicular to this line. These two angles are congruent. These two angles are congruent. All four sides are congruent. Now let's take a look at our last figure for the measurement of the angles. Line this up. And I know this angle is going to be larger than 90 degrees. So I need to be looking at this bottom row. So it's between 110 and 120. It's 115 degrees. This angle is going to be an acute angle. It's less than 90 degrees. So I'll need to make sure that I'm looking on the correct place on my protractor. This one comes out to 65 degrees. Okay. And we've already proven that parallelograms have opposite equal angles, or opposite congruent angles. So we already know that this angle is going to be 65 degrees and this angle is going to be 115 degrees. All right, so we followed the instructions on step one. We've labeled everything. Now it says, what attributes and properties do the parallelograms share? Remember, attributes is another term for characteristics. How can we describe it? And properties is what we've already been listing. We know that all of them have at least, or have two sets, all have two sets of parallel lines. We know that all have at least two sets of perpendicular lines. Or I'm sorry, not perpendicular. All have two sets of parallel lines. All have at least, or actually they have two sets of congruent length sides. So two sets congruent side lengths. So they all had two sets of congruent angles. So we talked about the parallel lines, we talked about the congruent sides, and we talked about the angles. So I think we've covered the three major things there. All right. Now let's take a look at the next one. Where do you think parallelograms get their name? So if I'm looking at parallel lines are lines that continue in two directions forever and ever 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 and never touch. So if I continued these two lines, I can take my ruler and do so. I can see that no matter how far they travel, they're staying the exact same distance away from each other. They are never going to touch. And we know that parallelograms get their name because they have two sets of parallel lines. Okay. So they have two sets of parallel lines. Okay. And now they're giving us the exact definition of a parallelogram. It says parallelogram, a quadrilateral, so that's four sides, with opposite sides that are parallel. Okay, we proved that up here. And of equal lengths. So it means that, and we proved that up here, these opposite sides are congruent, equal lengths. These opposite sides are congruent with equal lengths. Same here, same here. Okay. Now it says, are rectangles, rhombuses, and squares parallelograms? Justify your answer. Now, if I look at the definition of a rectangle, it is a quadrilateral with two pairs of equal parallel sides and four right angles. So we can just go ahead and draw a quick picture. Four right angles and two pairs of parallel sides. You've got that. So those two are parallel, these two are parallel. And this side is equal to that side, this side is equal to this side, okay? Now, a rhombus is a parallelogram with all four sides equal in length, okay? So it's a parallelogram with four equal sides. Okay. Squares are always figures that all four sides are the same and they have four right angles. Now this is where the definitions of these terms tend to get confusing. A rhombus is a parallelogram with four equal sides. Okay, so that means that a square is a rhombus, always. But a rhombus is not always a square because rhombuses may look like this. Kind of squished. So they could have smaller angles there, larger angles here, so it could be an acute angle, obtuse angles here, but these sides are still parallel to each other. But a square has four right angles. Rhombuses don't require four right angles. So this is where you've got to make sure you understand the definition of what makes a rhombus and what makes a square. Okay? And again, this unit, the hardest thing about geometry is the definitions. That's where people make the most mistakes. So, are rectangles, rhombuses, and squares parallelograms? Justify your answer. Well, a rectangle is always going to be a parallelogram because a parallelogram is a quadrilateral, so 4 sides, with opposite sides that are parallel, and of equal length. Well, for a rectangle, the top and bottom are always going to be equal in length, and the right and left are always going to be equal in length. So therefore, yes, rectangles are parallelograms. Now a rhombus, it says it in the definition that it's a parallelogram. So if you know that a rhombus is a parallelogram with 4 equal sides, then you know that rhombuses are automatically parallelograms. They have to have 2 sets of parallel sides. And then a square is a quadrilateral with 4 sides that are congruent and 4 right angles. So if you draw a square, it's always going to be a parallelogram. Always. Always, 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 always. Okay? All right, so that's why a rectangle, a rhombus, and a square are parallelograms. Okay? All right, now you can think about these 2 questions down at the bottom. It says, how did you use the critical thinking trait communicate in this activity? So how were you able to communicate your ideas and your thoughts about these questions, even if you're just talking to yourself in your head, or if you talk about this with a partner? And how did you use critical thinking traits in this activity? How are you linking things? Well, we're linking the concepts between the different shapes. We're also linking attributes and characteristics of different shapes and parallelograms. Okay. All right, well, thank you guys so much for hanging in there with me through this activity. I hope that you've taken the notes on this and that it has helped a little bit. I highly recommend, if you have not done so, go through all of our vocabulary and make yourself flashcards. It will help you immensely if you do that and you study them. All right, have a great day, everybody. See you next time.